Hey guys, this is Aryan Karani. I just took an AP practice test at my school and I've taken a lot of them. And I found out that one of my biggest weaknesses, compound Boolean expressions questions. Compound Boolean expression questions can be pretty confusing because you have this just gigantic, ugly Boolean expression, something like A or B and not A and B. The questions usually ask you something like, when is this expression true, or when is it false, or can this expression be simplified? A lot of the times, especially for those evaluating ones, when they're like, okay, you have this expression, when is this expression true, when A is false and B is true, and all of that stuff. So I'm going to show you a way to test out these methods. It's called a truth table. If you already know it, that's great. But I'm going to go through a few examples, maybe 2 or 3, of how to use this truth table so that when you're in the AP test and you're going through your thing and you find a compound Boolean expression, you're like, oh my gosh, this is so complicated. What do you do? So this is a great method. It's always going to work because it's literally just logic. Let's get into some examples. Okay guys, let's look at some practice problems from some past AP tests. So first I have the AP Computer Science A 2015 test, and here is our question. Assume that x and y are Boolean variables and have been properly initialized. Which of the following best describes the result of evaluating the expression above? And we have 4 options: true always, false always, true only when x is true and y is true, and true only when x and y have different values. The first thing we have here is our Boolean expression. I'm going to write that down right here. I'll write it down in a nice red color so it stands out. X and y and not x or y. There's a problem. And so for these kind of questions where it's asking you what best describes the result, and you have true always, false always, x and y are the same, I would suggest making this thing called a truth table, and this is how you make it. So here we have 2 variables, x and y, so I'm just going to write down in white an x and a y, and now we have 2 expressions, that's x and y and not x or y. So I wrote down those 4 in a line, and I'm just going to make a little table out of them. There you go. And now since we have 2 variables, the number of possibilities is that number of variables squared, so we have 4 possibilities for what these variables could be. We could have x is true, y is false, x is false, y is true, both of them are true, and both of them are false. Those are the 4 possibilities of our x and y variables. So now what we're going to do is evaluate these 2 expressions, and that are separated by the and in the middle, this and right here. So x and y, true and false. Obviously that would be false because x and y are not both true. False and true, again false. True and true, that would evaluate to true because both are true. And false would evaluate to false because basically x and y means that it's asking, yes, are x and y both true? Now let's evaluate not x or y. So x or y, true or false? One of them has to be true. So x is true here, so x or y would evaluate to true, but since there's a not there, it's going to negate that, so it's actually going to be false. Next, false or true, that would equate to true, but then negate it, you get another false. True or true, that would be true, and negate it, you get to false. False or false, that would be false, but negate it, and then you get to true. So for that, we first evaluated x or y, then we just negated it because of the not symbol, which is that exclamation mark. Zoom out here, and we're going to evaluate the whole expression. So here, between these 2 statements, we have this and, right? Circle that, this and so that's what we have to evaluate. So, and now we're just gonna actually take these 2 columns right here. So first, false and false, which is going to be make this blue. False and false is going to be false, and then false and false again is going to be false. True and false is going to be false, and false and true is going to be false. So here we can see that all of our values have equated to false, which means in these four options we have true always, false always, true only when x is true and y is true, and true only when x and y have the same value. The answer is going to be false always, because these are always false. So that is your truth table. It's very simple. You just evaluate the whole expression, what do you get, and you interpret the results. Now I'm going to show you one more way we could have gone about this. So I'm just going to delete everything and write down the expression again. X and y and not x or y. So in this one, what we're going to be doing is we're going to evaluate what do these expressions actually mean and what are they trying to test for. So first, let's look at x and y. What does x and y mean? It means that both x has to be true and y has to be true, because the only time that an and statement will actually be true is when both terms on the side of it are also true. So it's asking, are these both true? And let's assume that, you know, this is an if statement. And when will an if statement, you know, classify x and y as true is when both x and y are true. So I'm just going to draw an arrow. X must be true and y must be true. So another way you can think about this is, when is this expression true in terms of x and y, right? So now we're going to look at not x or y. So the x or y part of this x or y part of it, right? That would be meaning either x or y has to be true. So one of them must be true. So here we can say either x or y is true or must be true. But here we have a not. That means not x or y. And what that not actually makes this equation or expression is x must be true or y must be true, but you're not doing any of those, which means neither x and y can be true. So neither x or y can be true. And that's what that expression is really trying to say. And if neither x or y can be true, and the other expression says x must be true and y must be true, these two expressions are essentially negating each other. They're contradicting each other, which means the only outcome for any value of x and y must be false for this equation. So another way to go about it is just to logic yourself through it. But if you can't see that, or you know, it's a little confusing for you, I would suggest just use the truth table. So let's look at another example. Okay, so I'm looking at another question from the 2015 practice test. Here the question is x or y and x. Sorry, my and percents are kind of bad because I'm not great at drawing that. But x or y and x. And the question is, assume that x and y are Boolean variables and have been properly initialized. Which of the following always evaluates to the same value as the expression above? And our four options are a x, b y, c x and y, d x or y. So one way you could do this is make a truth table, right? So we have x or y and x. So let's make a quick truth table for this. We have two variables, x and y, and we have two expressions, x or y and x. So I'm just going to make a quick table out of this. Again, we have two variables, which means we have two. Oh, and I'm also going to just add final here to represent our final verdict for each value. So x and y, that's two variables. 2 squared is 4. We have 4 possibilities or combinations of these variables. We have true, true, false, false, true, false, and false, true. That F looks like a T with a line on it. False, true. So those are our 4 possibilities. Now let's go ahead and evaluate the expressions. X or Y, true or true, that's going to evaluate to true. False or false, that's going to be false. X or Y, true or false, that's going to evaluate to true. And false or true is going to evaluate to true. So we're done with our X or Y. Now X. X will just be, that X value. So X goes true, false, so we're going to just put true, false, false. For X, we're just putting in these values. And now final. There's an AND in between these two. So we're going to take the AND of the X or Y and the X. So true and true is true. False and false is false. True and true is true. True and false is false. Okay, so we're done with that. So we got true, false, true, false. With this truth table, we can check which expression in these 5 options, A, B, C, D, E. So X, Y, X and Y, X or Y, and X is not equal to Y. Which of them evaluates the exact same values? So let me just move these over to the side. So our first option is X. Put that in red. So A is X. Put that in blue actually. So A is X. So let's make a truth table for X. So there's 2 values for X, either true or false, right? Yeah, either true or false. But instead of saying true or false, we're going to actually evaluate X for all values of X and Y, right? We're going to act like we still have 2 variables. So I'm going to put an X, I'm going to put a Y. And you can probably, do this out of just sheer logic and common sense, but I'm just going to go through this. So we have X, and we have Y, and then we have our final, because there's no expressions really, we just have X. So there you go. But Y is an NA because there is no Y, so we don't even need this. So we're going to use these exact same values that we used for the X over here in the original expression. So our first X value was true, second was false, third was true, fourth was false, and final would just be true, false, because our final value is that X. So here we can see that actually the 2 match. So most likely X is going to be your right answer. So I'm just going to go down. I know Y is not going to be true because we look at our Y over here. Our Y with these values would evaluate to true, false, true, which is not equal to true, false. So that would not be true. Next, let's look at our C, which is X and Y. And this is probably the one I'm going to stop at because we know X is the correct answer. But X and Y. And let's make another truth table. So get my white pen. X, Y, final. Because the only expression we have is X and Y. Okay, so what were our values for X? True, false, and what were our values for Y? True, false, true. And now our question is X and Y. So X and Y, true and true, false and false, true and false, and false and true, false. So these two, this one over here and this one over here, do not match. So X and Y is not a correct answer. And this way you can see that with the truth table you can find out, what's the correct answer. You just have to find matching truth tables between the original expression and the answers, and just keep on testing until you find the right one, I guess. And of course you can also logic through this. Okay, so how you can logic through this is basically, let's go back to our truth table. So there's our final, and here you can probably just see that our X's over here and our final over here match, and Y and final do not match. So you can say, oh, if X and final match, then basically what you're validating for is just X. So that's how you can possibly logic through it. But if you don't see that, it's always good just to keep on testing the actual solutions. Okay, so let's look at one more complicated one where the problem is not A is not equal to B and B is greater than 7. That's our problem. And what it's asking for is, assume that A and B have been defined and initialized as values, the expression that is equivalent to which of the following. And we have A as A not equal to B, or B is less than 7. B is A is not equal to B, or B is less than equal to 7. C is A equals B, or B is less than equal to 7. D is A is not equal to B and B is less than equal to 7. And E is A equals B and B is greater than 7. So this looks a little complicated. So how do you go about doing this? One option is to go through, look at truth tables and all of that. But as you can see, with these complicated kind of solutions, it can take a long time. So I think the first thing you should try to do is, when you're doing the test, is go through the logic of it first. So not A is not equal to B. So A is not equal to B. What is that testing for? Basically, exactly what it means. A is not equal to B. So either A is true or B is false, or B is true and A is false. And it's not A is not equal to B. So what this basically means is A equals B. Right? So here we're just kind of simplifying it. And B is greater than 7. And this is, I think, the first one where we've seen a number in the mix. So it's asking A equals B and B is greater than 7. B is greater than 7. This is all surrounded by a big not. So everything here but not. So not A equal to B and B is greater than 7. Yeah, so all of this is surrounded with a big not. And what does this not really mean? It's basically either this is not true or this is not true, which would make this whole thing false and which would make the whole expression true. That sounds really confusing, but that's the thing. So either what would make this expression true when this inside expression, this one, is false, right? And what would make it false? Either A is not equal to B. So either A is not equal to B, or B is less than or equal to 7. Why equal? Because B is greater than 7, so have 8, 9, 10, 11. But if it's 7, this would be false. 7 is not greater than 7, right? So less than or equal to 7. And this is the end of our simplifying. And here we can see we have an exact match with this expression on option B. A is not equal to B, or B is less than or equal to 7. So when you have these big kind of questions with pretty large answers, it's best to try to simplify the expression. So first, okay, simplify the ones inside. Not A is not equal to B. That basically means A is equal to B. And B is greater than 7, that stays the same. But then this whole thing's surrounded by a not, so what will make that whole expression true is that if the inside expression is false. And to make that inside expression false, either A is not equal to B or B is less than or equal to 7, and that would make that inside expression false. And that's essentially canceling out this not sign. So I hope you learned something from this video. It's definitely very confusing, and I would just suggest, for the types of problems that are a little simpler, like that X or Y and X, just use a truth table, look through the answers, especially when the solutions are just as simple. Or if it's like this kind of really ugly problem, try to simplify the problem first. And if the solutions are simple, then maybe make a truth table. You might be able to find something. Or if the solutions are complicated, like this one, A is not equal to B or B is less than 7, just try to find an equivalent expression for that. Thanks a lot. This is Aryan Karani from Kid with the Camera, and I'll see you later.